Well, it turns out there's a problem with this term on the right side. This calls in a voltage that is not stored in the computer. If this moment here corresponds to the nth time step, and here is where the kth position in time is, then, right here is where VKN is. And we're looking for VKN plus a half. So that would be at the same location in space, so lined up with this, but in time it's a half a time step into the future. So that would be located here, and we can see that that is not included in our discrete number of voltages that we are storing. So what can we do about this? Well, we've strategically positioned these so that we can apply central differencing. And so this is a separate issue that comes about from solving the telegrapher's equation. And so we need a way to deal with this. And probably the simplest option is to average the two neighboring voltages that we do have. So, for example, we have this voltage and we have this voltage. We can use those two to approximate that one right there. So the way I would write this is Vk n plus a half is about equal to Vk at n plus 1 plus Vk at n divided by 2. I'm just going to do a very simple averaging of the two. So now here, all we've done is replaced with that averaging that we came up with, so that we're only using values that are stored in the computer. And now if we look at all the terms in this equation we've come up with for the first telegrapher's equation, they are all values that are stored in the computer, and we can now solve this equation. So this is the equation we just came up with. And if we went through the same process for the second telegrapher's equation, this is what we would get for the second telegrapher's equation. So here are the two equations that we want to solve. And so now let's take a step back here. How can we actually go about using these equations to solve for the voltages and the currents along the transmission line? We know that we can store all these voltages and currents in the computer, but how are we going to use these two equations to solve for the voltages and currents, the waves that travel down the transmission lines, and how they evolve over time?